Okay, so this is lecture 2. Continued to focus on statistics here. So let's talk about statistics. So statistics, woo! They collect, they analyze, they interpret, and they present data. That's what statistics do. So that's cool. Uh, let's talk a minute. We're going to talk. This first little. There's going to be 3 lecture chunks. This first lecture chunk, we'll talk about descriptive statistics. Right? These things we use to summarize what we call a population, or some collection of data. So we'll talk about that in a second, right? And the mean and the standard deviation, or the variance, the skewness, all these things that we'll talk about in a second, we refer to actually as moments, if you want to get really technical about it. And if you recall, right, a moment is a specific quantitative measure used in both mechanics and statistics to describe the shape of a set of points, right? So it's a way to describe how that data lie, or how a load lies on a beam, or that kind of stuff, or whatever, how a beam is bending, right? So in this case, we're going to talk about how our data distributed, and we're going to use our moments, like the mean, which is the first moment, to describe these things. Okay, so before we get there, let's talk about population, right, and samples. So a population, it represents all of the data, right, everything, and it's collected via this thing that we call a census, right? Whereas a sample, it just represents some of the population. So when we talk about population, and if we have all the data from our population, when we talk about the mean, which we'll describe in a second, we can refer to that as mu, because we're talking about a population. Inferential statistics, right? Use the sample to make inferences about the population. In this case, then we're talking about an X bar, not a mu, right? Because we only have samples and we're trying to describe the population. So remember, it's really hard to get all of the data, right? When we conduct the annual census, we get pretty close, or I'm sorry, the decadal census, we get pretty close to getting all of the data. But even then, we don't necessarily get all of it, and we have to impute some things. So sometimes we need to have all the data. Sometimes it's just impossible to have all the data. We only get a sample, right? And then we have to take information that we know about that sample and try to go backwards to describe the population. And you'll see why that's important when we talk about flooding in a little bit. Okay, so the mean, right, the mean, or mu, is the first moment of a distribution, and it measures what we call central tendency. And okay, so that kind of is a description of where all the data lie, right? It's mass. And it's defined mathematically as the 2 functions below. So you can either think of it as it's the summation of all the individual events times their probabilities for a discrete distribution, or something similar for a continuous distribution. Now, an important thing to remember, again, right, what's the difference between mu and X bar again? Whenever we use mu, we're talking about a whole population. We've got all the data, right? And if we don't have all the data, then we refer to it as X bar. Okay, the next moment we want to talk about is the variance. And the variance, it's the second moment, and is the expected value of the squared deviations about the mean. What does that mean? Well, let's look at the equation here. It's defined mathematically as sigma squared, or the expectation of x minus mu squared, right? So that's the squared deviations. What we're taking is every data point that we have, we're going to subtract it from the mean of all the data, square that value, and then take the arithmetic mean of all those deviations that we computed, right? So if you recall, the expectation here is just simply the arithmetic mean. So what is just sigma, right? What does sigma and sigma squared represent in our terms? Well, if you guys remember from stats, or if you haven't had stats, sigma is this thing that we call the standard deviation, right? And sigma squared is the variance. So what does this do? Well, let's look at some distributions here. So here we have some normal distributions, and I ripped this off of probably Wikipedia or something. And so here we see we have three distributions that have a mean of 0. So the bulk of the data kind of all lie centered around 0. But we have different variances, right? So if we have a really small variance, almost all the data is centered right close to 0. It's lied in there tight, right? And as we increase the variance, if we look at the orange colored line, we can see we have a really big variance, a variance of 5. And the data has become spread out, right? So the standard deviation, or the variance, or the second moment of a distribution basically describes how spread out the data are. Okay, so the third and kind of last moment that we're going to talk about is skew, right? And this is something that helps describe the shape of the distribution. So a skew of 0 indicates that the distribution is symmetrical. So let's take a moment and draw a distribution. Draw one that you think has skew equals 0, and draw one where you think skew does not equal 0. So here's our little lines. I'll give you a minute here to draw. Okay, so let's look. You guys should have hopefully gotten at least the skew equals 0 one, because I kind of gave you a hint there, right? We said a skew of 0 indicates that the distribution is symmetrical. So if you would just draw kind of a simple bell-shaped distribution, or any distribution that's symmetrical, this would have a skew 0. Now, some distributions, they're not symmetrical, right? The data are kind of might be bulged to one side and have what we call a tail, kind of trailing out to the other side. In this case, we'd have a distribution here where the skew is not 0. Okay, so the last kind of descriptive statistic we're going to talk about is the median. So the median's another measure of central tendency, but it represents what we call the 50th percentile of the data, right? And so one question is this more or less likely to get pulled by outliers? So let's look at this question, because now we're not talking about kind of summing up all the data and dividing by the total number of data points that we have here. We're talking about the 50th percentile of the data. So we're talking about ranking the data and looking at where the middle value is, right? And so here, for a normal distribution, something that's symmetrical here, the median in this case is equal to the mean, right? It makes sense. The 50th percentile is kind of right in the middle. But let's go back to our skewed distribution here. Here you can see I've got two dashed lines in there. The mean might be pulled way out to the right, because we might have some values that are very large and are dominating. So they pulled the mean way out to the right side of our little chart here, whereas the median, where the 50th percentile of all the data, if we rank it, is closer kind of back to where all the data are centered, right? So in this case, the median does not equal the mean. Okay, so we're going to go over one more slide here, and then we're going to start talking about distributions. So again, when we talk about descriptive descriptive statistics, we tend to talk about them in terms of these distributions again, right? So in hydrology, some of the most common distributions that we use are the normal and the gamma, but we also use some of these other ones: log Pearson, extreme value, y-will exponential, and the binomial, which you're now familiar with. So in lecture part 2 and lecture part 3 for lecture 2, we're going to focus on the normal and the gamma distributions.